class, we are talking about transformations again. Remember, this is something that moves or changes a figure to produce a new figure. And there are four basic transformations: translations, rotations, reflections, dilations. We've already talked about translations and reflections, so now we are on to rotations. A rotation is... No, get out of the way, man. Okay, sure. That is a rotation. It is a transformation in which a figure is turned about a fixed point called the center of rotation, and it draws rays from the center. Let's see, there's what I want. Draws rays from the center of rotation to a point to form the angle of rotation. So this angle of rotation drawn from here, the pink ray to the other pink ray, so from point B to B prime, and let me get a protractor here, and you'll see. So I'm going to center this on the center of rotation, and we'll see that this rotation for the pink, if it'll line up, there we go. For the pink, we see that this angle of rotation is 75 degrees. If we go and we look at it, stop it, okay. For point A to A prime, we see that is also, come on, there we go. We see that is also 75 degrees. Same thing if we look at from point C to C prime, 75 degrees. So all of these rotate the same degree, and so we have a rotation. One of the things that also means is the shape doesn't change. It's the same size. It's congruent to each other. It just changes the orientation. It's just facing a different direction. All right. All it does is change the orientation. The shape doesn't change itself. All right. So let's take a look at this. What we're going to do here, we are going to rotate 90 degrees about the origin. Notice it does not say which direction. Unless the problem says otherwise, it's always going to be counterclockwise. So it's always going to be moving in this direction like so. All right. So what we're going to do with this, we are just going to take this and we want to rotate it 90 degrees around the origin like that. This is counterclockwise. All right. And so let's give me that. There we go. So we have A moves to A prime, B moves to B prime, C moves to C prime. And let's see if we can't get the points up here. So the pre-image, remember the pre-image always comes first. Image comes second. Here are the points. And what can we say about these points so that we can have a rule, something we can look at and just do this real easy without having to need the graph? Well, let's look at here. Negative 5, 7 turns into negative 7, negative 5. Negative 6, 2 turns into negative 2, negative 6. Negative 2, 2 turns into negative 2, negative 2. So look at this. The numbers all stay the same. They just change positions and stuff, change signs, right? So what we have, with a 90-degree rotation, we end up with negative yx. So the number in the back, the x value moves to the back. The y value moves to the front and changes sign. X value moves to the back, y value moves to the front, changes sign. X value moves to the back, y value moves to the front, changes sign. So you see, that's all that happens is we have negative yx. So the x value moves to the back, y value moves to the front, changes sign. And so we can do this without needing a graph. All right. So that's a 90-degree rotation. Remember, this is going to be a counterclockwise rotation. How many degrees would this be if I moved clockwise? That would be 270, right? Because moving from this quadrant would be 90 degrees. Another 90 is 180. Another 90 is 270. So this would be the same thing as a 270-degree clockwise rotation. Okay, so let's take a look at the next one. We have 180-degree rotation about the origin. So first, let's go ahead and take this. We're going to spin it 180 degrees counterclockwise, because it doesn't say to do it any other ways. So let's see here. That would be 90 and 180. So right there. All right. So 180 degrees is going to put that there. Give me my A prime, B prime, and C prime. All right. And let's take a look at our points. So same pre-image. Our image is now at 5, -7. It was at -5, +7. Now it's at +5, -7. We have -6, +2 turns into +6, -2. And -2, +2 turns into +2, -2. So what happened here? Well, we've got the same numbers. They're in the same order. They just changed signs, didn't they? And that's all we do. So for a 180-degree counterclockwise rotation, all we do is we take our x and y and we change the sign. If they were negative, they become positive. If they were positive, they become negative. All right. Notice this is very similar to a reflection over the line y equals x, but it's not the same. Okay, it has a different orientation, so you got to be very careful of that when you're looking at those. All right. So again, all you do, you just change the signs on everything. Positive becomes negative, negative becomes positive. So this is a 180-degree counterclockwise rotation. How many degrees would that be if it was a clockwise rotation? Now, that would be 180 degrees, because it's halfway this way, halfway that way, you end up in the same spot. Okay, so the next one is going to be a 270-degree rotation about the origin. Again, counterclockwise. So we've got 90 degrees, 180 degrees, and so one more, here we go, is 270, get lined up properly, there we go, 270-degree rotation about the origin. Counterclockwise, always, unless it says otherwise. Okay, so let's take a look at our points. So again, the pre-image we have is at -5, 7, and that turns into +7, +5. -6, 2 turns into +2, +6, and -2, 2 turns into +2, +2. Okay, so let's see here. Same numbers. See, our y value moves to the front on all of them and stays the same, and our x value moves to the back, and that changes sign. So that's what we have here. Y, -x. So for a 270-degree rotation, we just take the y value, move it to the front, and the x value moves to the back and changes sign. Okay, very, very similar to the 90-degree rotation, right? So you got to be very careful with those. It's easy to get those mixed up. So pay very close attention to these rotation rules. They're all very similar, easy to get mixed up. I strongly suggest writing them down. So this is a 270-degree counterclockwise rotation. How many degrees is this as a clockwise rotation? Now, that would be 90 degrees. We just moved over one quadrant, right? So 90 degrees clockwise or 270-degree counterclockwise. And if it doesn't say which direction to move, then you're moving counterclockwise. All right, so we've got one last thing to look at here. Rotation about a point that is not the origin. Okay, and this is a little bit trickier. So what we're going to do, we are going to rotate 90 degrees about the point -1, 3. Okay, so 90 degrees, it doesn't say which direction to go, so we're going counterclockwise, right? And so that is going to do, first we're going to take a look at this, and then we will see how to do this algebraically. All right, there we go. So rotate this counterclockwise from that point, and we end up here. All right, so there's our A prime, B prime, and C prime. Not rotating around the origin, we're rotating around the point -1, 3. So here are our points, and notice this doesn't look very good for having a rule, right? It's, I mean, these numbers, this one, the x value from A stayed the same, but didn't stay the same here. Y stayed the same there, it changed everywhere else. So no good for having a rule. So it takes a lot more work on this one. So let me just put that all back. Get that back up. And we will look at this, how to do this algebraically. So algebraically, basically you can't rotate around a point that's not the origin algebraically. So what we need to do is we need to take this and we need to move it to the origin. Well, to move it, that's just a translation, right? So all we have to do is that translation. We're going to add that vector, which you'll notice we're just moving down 3, right 1. That's the opposite of what our point was. So that's what we're going to do. We're going to add the vector of -a, -b. So negative of -1 is +1. The negative of +3 is -3. So we're just going to add 1 -3 to each of these points, and that puts us right here. So we see we're at -4, 4, -5, 1, and -1, -1, or -5, -1. All right? So that's what happens first. Then from here, we're going to do the rotation. So it's a 90-degree rotation, so that's -y, +x. So y moves to the front, changes sign, x moves to the back. Y moves to the front, changes sign, x moves to the back. Y moves to the front, changes sign, x moves back. And so let me go ahead and do that graphically. There it is. All right. So you see, same spot. We're at -4, -4, 1, -5, and 1, -1. But we rotated it from the wrong spot, right? Now we got to move it back because we've done this translation before. Now I need to translate everything back to -1, +3. Puts me here. So I'm just going to undo this vector. So I did subtract them. Now I'm going to add them back in. So -1 puts you -5, +3 puts you +1. 1 minus 1 is 0, and -5 + 3 is -2. 1 minus 1 is 0, and -1 + 3 is 2. So like that. And so you see, we end up in the same spot, but this is how you do it algebraically. And this one does take a bit of work, I'll admit. Okay, not the fastest thing to do, but it can be done algebraically. It just takes a bit of time. So again, what you do is first you do a translation. You subtract this point from each of our vertices. Then you do the rotation, whatever the rotation rule it is, but 90 degree, 80 degree, 270 degrees, whichever rotation rule you have. And then you add that point, your center of dilation, back into all of this. You undo that first translation. All right? And that's how that works, which does take a bit of time. It's not especially difficult. It's just adding and subtracting, right? Change some signs or some stuff. But it does take some work. All right? So again, let's see here. The 270 degree counterclockwise rotation, the rule is y negative x. For a 180 degree counterclockwise rotation, our rule is -x negative y. And for a 90 degree counterclockwise rotation, the rule is -y positive x. And that is rotations. Hope you found that useful, and I will see you in the next video.